Now we're on 3C.5 polynomial functions, and we're going to be writing polynomial functions. Again, this section is all non-calculator, so let's see how we do. The steps to writing a polynomial function are actually pretty easy. The first thing we're going to do is write/identify our zeros. So we're going to write and identify our zeros. Then we're going to turn them into linear factors. You're probably like, what is a linear factor? Well, the linear factor is just when you are writing it in the factored form that helped you find the zero. So that x minus c. The c is going to always be opposite of what you have. Then you're going to multiply the factors together and simplify. And then you'll have it in standard form. When we're writing a polynomial function, that's our f of x equals, and you have your leading term, ax to the n, so whatever power that may be, plus bx to the n minus 1, plus cx to the n minus 2, plus dx to the n minus 3, plus dot, 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 dot. So you understand that example. So for an example, f of x equals 6x to the 6 minus 5x to the 4th plus 3x to the 3rd plus 1. Okay? Sometimes you have some of the spaces and sometimes you do not. You just multiply out until you get what you get. And that's it. I thought I was making that better, but I definitely made that worse. All right. So our first example. So our first example, it says we're going to follow the steps. We're going to write / identify the zeros. So it tells us you have zeros at -2, 2, and 3. So step 1, done. Identified them. Next is to write them as linear factors. So our linear factors are going to always be opposite of what they are. So our first zero that we had is -2. So its linear factor is x plus 2, not 3. Okay. Then we have our next factor is our next zero is 2, so its factor is x minus 2. And then our last zero is add 3, so we'll have x minus 3. So now you have your linear factors. After you have your linear factors, you now are going to multiply the factors together. Remember, you only can multiply 2 factors at a time. I just typically multiply from left to right and work my way down. I'm going to do traditional distribution. If you are a box person, you can always make a box, but traditional distribution, here we go. X times x is x squared. X times -2 is -2x. 2 times x is 2x. 2 times -2 is going to give me -4. I can simplify this, and I get x squared minus 4 is what I'm down to. I'm going to bring down the factor that I did not use, which was x minus 3. And I'm going to distribute again. X squared times x is x to the 3. X squared times -3 is -3x squared. -4 times x is -4x. And -4 times -3 is going to give me +12. So therefore, once I finish step 3, all said and done, this is the polynomial model, or a possible polynomial model that would have those zeros. Okay. All right. You can always reverse check yourself using factoring. Let me see if you get back to the zeros. Our next example, I'm going to give you time to practice, so you're going to pause and follow along and see what happens. Okay, so you'll pause, come back. All right, welcome back. So we're going to start off with identifying our zeros. Our zeros are -2, -2, 2, and 3. So step 1, done. Step 2 is to write each zero as a factor. So writing them as a factor, we have x plus 2 times x plus 2 times x minus 2 times x minus 3. So again, remember, your binomial writings are going to always be the opposite. So if my zeros are -2, then when I write it as a binomial, it's going to be x plus 2 because that is how I got the zero of -2. All right, step 3 is to now multiply. So now we're going to multiply. And again, you only can do 2 at a time. So I'm going to do these two together, and then multiply them together. Okay, so quickly multiplying them together. I'm going to show you right here. If you, again, are a box user because you need the organization, I'm going to do, sorry, I can do it underneath. I'm going to do each one as the box, just to remind y'all how to do the box if you, again, prefer the box. So this one we're going to do with the box. So you have x and positive 2. You have an x and a positive 2. Filling in the box, we get x squared, 2x, 2x, and 4. What do we do to fill in the box? We have x times x makes x squared, x times 2 makes 2x, x times 2 makes 2x, and 2 times 2 makes 4. Now that we have our box filled in, we're going to combine like terms. Our like terms are on the diagonal. So we're left with x squared plus 4x plus 4. And now we're going to do the box on this one. So again, draw my little box. Remember, this is like the Punnett square of math. So we have x, negative 2, x, negative 3. X times x is x squared. X times negative 3 is negative 3x. X times negative 2 is negative 2x. And negative 2 times negative 3 is positive 6. Again, we're going to combine our like terms. Your like terms are along the diagonal. So we're left with x squared minus 5x. I'm going to write that a little better. X squared minus 5x plus 6. All right, so we now have two trinomials. They're trinomials because there are 3 terms in each. Binomials have only 2 terms, remember? So now we're down to these two trinomials that we're going to multiply. In order to multiply these 2 trinomials with the box, you're going to need a bigger box. Your box is based on the number of terms you have. So in this case, we need a box that's going to be a 3 by 3. Pretend that's the best looking box you've ever seen. And all of these are the straightest lines. Okay, so I'm going to put x squared, 4x, and 4. And then we have x squared and negative 5x and 6. Okay, I am modeling the box method, but do you have to use the box method? No, you can do traditional multiple distribution, which would be, if I was doing that, that would be x squared times x squared, which would go in this box. Then we would have x squared times negative 5x, which goes in this box. And then we'd have x squared times 6, which goes in this box. So we're doing the same thing. We're just doing it in a way that seems better organized for some. So x squared times x squared, that means we're adding the powers together, which gives us x to the 4th. X squared times negative 5x is going to be negative 5x cubed. X squared times 6 is 6x squared. Tried to make that work. Only got 6x squared. 4x times x squared is going to be 4x cubed. 4x times negative 5x is going to be negative 20. Ooh. My little boxes. Oh no! I erased my line. Come back. All right. I'm going to be negative 20x squared. 4x times 6 is 24x. 4 times x squared is 4x squared. 4 times the negative 5x is negative 20x. And 4 times 6 is 24. All right. So to write your function, f of x equals, we're going to, on the diagonals, that's where your like terms. So we have our cubes, we have our squares, and we have our linear terms right there. We're going to add them together. We're going to combine them. So our final answer would be x to the 4th. I have 4 plus negative 5, which is negative 1x to the 3rd. I have 4 minus 20, which is negative 16. Negative 16 plus 6 is going to put us at negative 10x squared. I have negative 20 plus 24, which puts us at 4x. And then we have 24. And that would be our possible polynomial model. I feel like that 24 looks like a 9, so we're going to try to make it more of a 4. Okay, so you can do traditional distribution or you can use the box method. Either way, as long as you're following these steps of identifying your zeros, writing your zeros in factored form, and then we're going to multiply. Multiplying is going to be the biggest part of it, so make sure you take your time to multiply. You only can multiply 2 binomials at a time, and then we came down to these 2 trinomials. And again, traditional distribution is perfectly fine. The box is just a way to help you stay organized. All right. On to our next. So our next examples, instead of having your zeros listed, you're going to be given a graph. From that graph, your job is to identify the x-intercepts. Once you identify the x-intercepts, you're going to write them as linear factors. Pay attention to multiplicities, meaning pay attention to how they're behaving around the x-axis, okay? You're going to then write the polynomial function in factored form. So you should have f of x equals, and notice we have this a here. So f of x equals a times x minus r1, which is our first root, x minus r2, our second root, and dot, 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 and it continues, okay? Then we're going to identify the y-intercept and substitute the 0y in to solve for a. If not available, we're going to use the smallest valued point available, okay? And then we're going to write the polynomial function with the a value, all right? So we're trying to find the exact polynomial to match what's being given. So here's our function. So we're going to go through these steps and follow exactly what has been listed. So step 1 is we're going to identify our x-intercepts. So looking at this graph, we have an x-intercept at negative 3, 0, 3, 0, and 5, 0. Okay, so identify the x-intercepts, check. Second step is to write your x-intercepts and as binomial factors. So we're going to write them as binomial factors. So we have step 2, x at negative 3. It is a normal x-intercept. We are not tangent to it. We're not slowly going through it. We are just crossing at negative 3. So that's just going to be a single binomial factor of x plus 3, and that is it. Same thing happens at 3 to 0. So it's just going to be x minus 3. Same thing happens at 5, 0. So it's just going to be x minus 5. All right. The next thing we're going to do is write the polynomial function in the factored form. So writing it as a factored form, that's going to be f of x equals a times x plus 3 times x minus 3 times x minus 5. Okay. After we do that, we're going to identify our y-intercept so that we can solve for our a. So we're going to identify our y-intercept. So going up here, our y-intercept is at probably not the best color to choose. Green on green. Let's just do orange. It's at 0,90. So at 0,90, that's our y-intercept. So step 4 is to identify your y-intercept or choose any other smaller value. Well, there are smaller values, but that one's y-intercept is ideal. So our y-intercept is at 0,40. All right. Next, we're going to, this is the part where the math comes in. You're going to write the polynomial function after we solve for our a. So we're going to solve for a. So we're going to plug in 0 for x, 40 for y. So when we're solving, we end up with your f of x is your y. So we have not 40, it's a 90. So in this case, my 9 look like a 4. So we need 90. There we go. So we're going to substitute that in. So we have 90 equals a times 0 plus 3, 0 minus 3, and 0 minus 5. So we get 90 equals a times 3 times negative 3 times negative 5. Okay, we're going to find that product, and then this is what we're going to divide by to find our a. So we have 3 times negative 3, which is negative 9. Negative 9 times negative 5 is positive 45. So we're dividing by 45. So we divide by 45, and we get our a. So 90 divided by 45 is 2. So our a equals 2. So now we have our a, and we can write our polynomial function. Unless it asks you to, on part 5, you can just write your polynomial function as f of x equals 2 times x plus 3 times x minus 3 times x minus 5. If it asks for you to write it in standard form, so this is in factored form, if it asks you to write it in standard form, then you're going to need to go through and distribute and write it in factored form. So this would be our, and in standard form, so this is our, sorry, it's the right solution. This is our factored form. Okay, if you want to write it in general standard, then you would need to go through and distribute the two, multiply, then multiply. Okay, all right. Okay, so you remember I said if it didn't want it in factored form, that means that you would have to go ahead and distribute. So we're going to go through distributing to distribute. So we have 2 times x, which is going to give us 2x. We have 2 times 3, which is going to give us 6. And we're going to do the next one. So over here, we have x times x, which gives us x squared. We have x times negative 5, which gives us negative 5x. We have negative 3 times x, which gives us negative 3x. And we have negative 3 times negative 5, which gives us positive 15. Okay? In all honesty, if you don't want to clean up before you continue to multiply, then go for it. I personally am going to combine these like terms. So negative 5x and negative 3x is going to make negative 8x, and that's what I'm going to use. So I'm going to use the negative 8x when I distribute so that I don't have to, I can save myself some time in the end. All right, so now you're going to keep multiplying again. So now you have 2x times x squared, which is going to give you 2x cubed. You have 2x times negative 8x, because that's what these two combine to make, which is going to give us negative 16x squared. And you have 2x times 15, which is going to give us positive 30x. Now you're going to do 6. So you have 6 times x squared, which gives us 6x squared. And then you have 6 times negative 8x, which is going to give us negative 48x. And then you have 6 times 15, which is going to give us 90. And we get 90. So now we're going to combine our like terms to find our function in standard or general form, as some may call it. So we have 2x cubed, and we have negative 16x squared and positive 6x. So negative 16x squared and positive 6x squared is going to make negative 10x squared. And then we had 30x and negative 48x. 30x and negative 48x is going to make negative 18x, all plus 90. And that would be our standard / general form. Okay? A little bit of multiplication goes a long way. All right? Again, if you're a box method person, you can use the box method. Last one. Let's try it again. So let's talk about this one. So at this one, we have 1, 2, 3 x-intercepts. So we're going to we identified our x-intercepts. We have negative 2. We have 3, 0, and 2, 0. Okay, it's kind of hard to tell, but at 2, 0, it actually is a double multiplicity. So looking, and the reason why is because if you look at our values, it's going up, and then it has to go up again in order to go down. So even though it's not zoomed in enough, we're going do. It's a little up in there, and then it's going to come back down. Because if not, then it would be going this way if it did not have that double. So what we're going to do is we're going to go ahead and label what we have. So when we label, we're saying that this is a single, this is a double, and this is a single. What that's going to help us do is when we write our binomial factors, we know to put a power or not a power on them, okay? So let's get this show on the road. So step 1 was to identify your x-intercepts, check. Step 2 is to write your x-intercepts as binomial factors, okay? as linear factors, so in binomial terms. So we had x minus 2, so this has to be x plus 2. We had x equals 2, so this has to be x minus 2, and it's a double, so it's going to be squared. And then we have 3, 0, so this has to be x minus 3. All right. We paid attention to our multiplicities. We wrote all that out, so we're golden. Now it says you're going to write it as a polynomial function. So when we're writing in a polynomial function in factored form, that means we have f of x equals, and there's an a term that we do not know yet. Okay. 4 is to identify your y-intercept. So we're going to find the y-intercept, and from the y-intercept, we're going to use it. So our y-intercept is at 0, 12. So on 4, we know that the y-intercept is at 0, 12. We're going to take 0 and 12, and we're going to plug them in for our x's and y's to help us find our a. X's and y's helps us find our a's. So f of x, remember, is the same thing as y. So we have 12 equals a times 0 plus 2 times 0 minus 2 squared times 0 minus 3. That's going to give us 12 equals a times 2. Negative 2 squared is going to give us positive 4 times negative 3. Okay. We're going to divide by their product. So 2 times 4 is 8. 8 times negative 3 is negative 24. So we divide by negative 24. 12 divided by negative 24 means that your a equals negative 1/2. Okay. 5 is to write your polynomial function. So we'll write our polynomial function. And we get f of x equals negative 1/2 times x plus 2 times x minus 2 squared times x minus 3. And again, this is our factored form. And if it did not want it in factored form, then we would need to distribute. So this is in factored form. So we would distribute. And you only can distribute 2 things at a time. And that is it. Okay, so as I was saying, is that this is our factored form, and if it wants it in standard general form, then you're going to have to FOIL and or distribute. I'm going to say personally, I wouldn't worry about the half until the end. So we're going to worry about the fact that these are our factors. So right now we have x plus 2 times x minus 2, and the square means that I have 2 of them, times x minus 3, which should bring you back to thinking about our previous problem that we did, where I went through it and did it as the box method. Okay, so we're going to multiply these 2 together, then these 2 together, and then multiply them all together. Okay, so we distribute x squared times x squared gives us x squared. X times negative 2x is going to give us negative 2x. 2 times x gives us positive 2x. And 2 times negative 2 is going to give us negative 4. That's one done. Now we're going to do the other one. X times x gives us x squared. X times negative 3 gives us negative 3x. Negative 2 times x gives us negative 2x. And negative 2 times negative 3, oh, I got a little excited there apparently, is positive 6. Okay, we're going to clean these up by combining like terms, combine like terms. Combine like terms. These like terms, thankfully, are going to cancel out. So we're left with x squared minus 4 times x squared minus 5x plus 6. Okay, and now we're going to distribute again. So we have x squared times x squared, which is x to the 4th. X squared times negative 5x, which is going to give us negative 5x cubed. Then we're going to do negative 4. So we have negative 4 x squared negative 4 times negative 5 is positive 20x. And then we have negative 4 times 6 is minus 24. All right, so now I think I'm done, but am I done? No, that's because remember I just said to wait off to the end for that 1/2, right? That 1/2 is here the entire time. So even though I'm not using it, I have this negative 1/2 here, negative 1/2 here, negative 1/2 here, and now I'm going to apply that negative 1/2. So I'm going to distribute to all of my terms. So you get a negative half, you get a negative half, you get a negative half. When you're dividing by, multiplying by a half, that's the same thing as dividing by negative 2. So I'm dividing this by negative 2, dividing this by negative 2, dividing this by negative 2, dividing this by negative 2. Okay? So when it's all said and done, our f of x equals negative 1/2 x to the 4. Negative divided by negative is a positive. So 5/2 x to the 3rd. A negative divided by a negative is a positive. So plus 2x squared. A positive divided by a negative is a negative, minus 10x. And a negative divided by a negative is a positive. So plus 12. And that would be our general / expanded form. Standard / general. Sometimes I'd be really concerned about my handwriting. All right. General. Close enough. Okay, so that concludes all of 3.5. I'm sorry. Yeah, 3C.5. It is a pretty lengthy lesson between the 3 parts, but it covers all the major things in this section. If you have any questions, comments, or concerns, please let me know, and then proceed to Canvas for your assignment.